All right, so we are going to look at the derivative of e to the x. So one of the most intriguing and useful characteristics of the natural exponential function is that it is its own derivative. Okay, so what we have here is that the derivative of e to the x is e to the x, but if we have that stuff in there, it's e to the stuff times the derivative of the stuff. You can interpret this theorem geometrically by saying that the slope of the graph of e to the x at any point is x comma e to the x. It's really quite cool. So let's look at it, and we're only getting to example 3, and then I have a handout we're going to do with this. So if the derivative of e to the x is e to the x, or if it's e to the u, it's e to the u times u prime. In letter A, if I want the derivative of e to the 2x minus 1, it's e to the 2x minus 1 times that derivative of the exponent. So this is 2e to the 2x minus 1. All right, try letter B. Okay, so this is e to the negative 3 over x, but then you have to take the derivative of that. What I would suggest you do is rewrite that as negative 3x to the negative 1, right? And then instead of attempting a quotient rule, we can do not even a product rule, we can just do the power rule, right? So you bring down the power, so that's 3x to the negative 2. Now, we do not leave a negative exponent, so watch what's going to happen. My 3 is the only thing that's going to stay up, and then that's going to become an x squared, and then my e to the negative 3 over x is going to drop to e to the positive 3 over x because it was a negative exponent, okay? All right. So now, let's take a look at the handout I gave you. Again, that's as far as we were going to get on that sheet. So now we're going to really practice. If f of x equals e to the x, f prime of x, e to the x is just e to the x. In number 2, now I have stuff there. So that's e to the 2x times the derivative. So if you're comfortable, you can just put it out front, right? So in number 2, that's f prime of x is 2e to the 2x. Yes?
How do you know when to use the ln instead of the e? Because like before...
Okay, we were solving an equation. That was solving an equation. Now we're doing a derivative.
Okay.
Yeah. Okay, try 3. F of x equals 2e to the 5x. Are you guys getting 10e to the 5x? Notice that this was not the product rule because it's 2 times. It's just a constant. In number 4, I have f of x equals e to the negative x. So f prime of x is e to the negative x times the derivative of that exponent. So that's negative e to the negative x, And then what should we do with that? Good job. So we're not going to leave a negative exponent typically. So then that would be negative 1 over e to the x. All right, try number 5 if you haven't already. F of x equals negative 3e to the negative 4x. All right, are you guys getting 12 over e to the 4x? Okay, this is actually pretty easy. Now, in number 6, f of x equals x e to the x. What is different about number 6 than all 5 of the other problems? We have a variable product, okay? So this does require the product rule. So here we go. This is going to be e to the x times the derivative of the first plus the first times the derivative of the second. So this is e to the x plus x e to the x. This is a correct answer. I will tell you though, on the AP exam, oftentimes they will factor out that e to the x. So I just want you to be comfortable. You don't have to, like on my next quiz, we have a quiz on Friday on 5-1, 5-4, 5-5. So you don't have to go that far with me, but when you're picking a multiple choice and you don't see this one, I want you to know why. All right, try 7, 8, 9. Okay, try all 3 of those. I'll pause them